Hello everyone, my name is Marie Karekla and I am ERA's Engagement and Program Coordinator. I would like to welcome everyone today to the iHub Summit 2 webinar series. Today's webinar is on Integrated Design Studios and it's the first webinar series taking place this week. Just before we begin, if you have any questions throughout the webinar, please use the Q&A function that's located just at the bottom of your screen, and we'll allow for some time after the formal presentations to go through any questions anyone may have. So now I would like to pass things over to ERA's Chief Executive Officer and the Chair of the Innovation Hub for Affordable Heating and Cooling, Tony Gleeson. Thank you, Tony.
Thank you, Marie, and hello everyone, and thanks for joining today. As Marie touched on today, this is really about the concept of showing in action the Affordable Heating and Cooling Innovation Hub, which is really applying principles to help us to drive to a low emissions future. And before we begin that journey today and hear from various participants of that process, I think it's always worth recognising on the lands that we actually currently meet. And I'd like to pay my respects to the traditional custodians of the lands of wherever we meet today within Australia. I'd like to pay my respects to elders, both past, present and emerging, and recognise and celebrate the diversity of the Aboriginal peoples. We recognise how they've looked after the country and protected it and cared for it for many thousands of years, and their ongoing connection, land, water and community we recognise and celebrate. So on to today. All these projects and all what we talk about today would not have been possible without this project being funded through ARENA, the Australian Renewable Energy Agency, and it's part of the Advancing Renewables program. iHub is effectively a $20 million project, which basically has contributions from both industry, government, and as well as private investment as well. And subsequently working together, it's really working together in this environment to be able to provide a very integrated platform to be able to drive to, again, that low emissions future. So today we're going to hear from Brendan McNiven and the team from the University of Melbourne, who've been working around the integrated design studios. And in particular, these studios have had a number of partners, and I'd like to thank their involvement, not only ERA, but Arup, Oricon, Greenbox Architecture, Grimshaw Architects, as well as project participants, and that is Queensland University, University of Wollongong, NEXTDC, and the ACT government. And as you can see, it's quite a contribution and quite a connected group of people and bodies we've been investing into this project. So it's great to hear what progress we've done and the adventures that this has gone down. So I'll hand you over to Brendan.
Thanks very much, Tony. And I'd just like to echo your thoughts on welcome to country. We appreciate the traditional custodians of the land, past, present and emerging. So I'm going to give a little bit of an introduction today. Then we've got a few people, Dominic Holzer, talking about the actual mechanics of integrated design, and then we'll share some experiences, technical findings, and actually what it was like working through the integrated design process in the studios. So what is iHub? Tony touched on this. So it's actually quite a large research hub. It was instigated through ERA in response to the Paris Climate Accord of 2015. So there's three platforms. There's data clearing, which is actually run by CSIRO. There's Living Labs, which is QUT and University of Wollongong, and then Melbourne University are looking after the integrated design studios. I should add that we're doing the majority of the studios at University of Melbourne, but QUT and University of Wollongong are also coming on board to do some studios in Queensland and New South Wales, which will be good. So why is it important? The Australian building and construction industry is a heavyweight in terms of carbon emissions, and energy usage across the board. So any gains that we can make in better performing buildings and reducing energy use and greenhouse gas emissions has a significant effect on the overall equation. So it's particularly worthwhile looking at design, because from design, all things flow in terms of building technical performance. So integrated design is really just looking at multidisciplinary design. So disciplines working in tandem with each other, as opposed to competitively with each other, which is sometimes the case, or where there's not really competition, just one particular discipline getting all of the focus to the detriment of other disciplines. So in particular, in the studios, we're interested in that nexus between client, engineer and architect. We believe that if you can actually solve the architecture and engineering together, you get a better performing building with better amenity for the building users. And the architects and engineers are obviously key in that, and you can't do that without the client. So the client is briefing, is guiding the project on the way through. So we believe if we can solve that three-way triad, that actually seeps out into the rest of the project team as well, the quantity surveyors, the contractors, the project managers, everybody else. So the studios are basically set up on the basis of the architectural program, the Masters of Architecture at Melbourne University. So architectural students do projects each semester where they design a fictitious building. There's 16 students per studio, and they're overseen by a design tutor. And sometimes you get the odd consultant coming in to help them out, but it's mainly a fairly fictitious process. We're changing that to actually get them to look at real buildings, and we're bringing in real consultants from industry, so practicing architects and engineers and other technical specialists to actually help them design through an actual building. And in that process, we're using that as a microcosm of a design environment to look at how the interaction between architecture and engineering works, to try and learn some lessons as to how to make that work better in practice. So there's a lot of literature out there on the theory about how you're getting it to work, and we're interested in how it actually works in practice. At the end of the studio, the 16 students generally end up with 16 projects. Sometimes they do group work. In particular, with the integrated design studios, there's a bit more of that because we have not only architectural students, we're actually introducing engineering students as well. So you end up with anywhere between 8 and 12 different projects being designed, and essentially they're producing a design somewhere between concept and schematic design level of particular building typologies, and throughout all of that they're exploring how to get the architecture and engineering working better together, and in particular with a focus on renewable energy and reduced energy consumption in line with ARENA's remit. The best way to think about integrated design, I think, is that the whole is greater than the sum of the parts. So actually you can design better buildings together than you can design alone. In terms of the bigger context and the overall process, essentially it happens in 3 main phases. That's the first one. We do the actual studio where we have developers and clients, academics, consultants and students in the design studios all working on different building typologies. So the first 2 were schools and data centres. We then actually finish up that 15, 16-week process. Students submit all of their ideas and the concept designs for the buildings. The consultants that were involved actually take a lot of those ideas and they do some very rough numbers on them, back of envelope, to actually see whether they're actually good ideas or there were ideas that looked good back in the flurry of the design studio, but actually once you did the numbers on them, they're marginal or not that good after all. And the idea is that they actually, we hope that out of the 8 to 12 different projects and all of the ideas involved in those, we come up with a handful of ideas that are worthwhile actually taking forward. And once we take those forward, the clients involved get first right of refusal in terms of using those ideas, as do the consultants and other people involved in the design studios. And a couple of those ideas have already been mooted about being taken forward and used in actual projects. And regardless, we will actually publish them in public, and so they're there for industry to actually take up if they'd like to take them up as well. So the first two studios that we've done were IDS 01 on data centers, which was with NEXTDC as the client, Greenbox as the architects, and Oricon Engineering. And then the second one was with the ACT government looking at schools, and that was with Grimshaw acting as the architects and Arup as the engineers. So with that, I'll pass you over to Dominic, who's going to share a little bit about the detail of how integrated design worked in the studios and what we put forward to try and make things happen.
So my name is Dominic Holzer. I'm the research lead on the IDS program, and I will briefly take you through the background, sort of the setup, if you want, on what we thought about how we put these studios together, what we want to find out really via the integrated design program from a research perspective. And this will hopefully give you also some insights on how the outcomes were ultimately derived and how they're being used. I will follow up with a few things that Brendan has said, but I will go into more depth on some of them with brief introduction, really basics of integrated design, and then I'll give you my take on the IDS context. And yeah, I would start with the prevailing style of thinking that we often see in the industry. So we are doing this because we are an industry that works jointly on projects, but interestingly, the mentality we often still see, even though we should assume that everyone has the same goals on a project, we typically see that those goals are not always clearly defined. We see that people come with their own professional bias. We see that there are cultural obstacles, cultural hurdles, and really working against that sort of style of thinking that very much starts already in education. And this is why it's so important. This is why I'm personally so grateful to have ERA here as a partner and Arena as a partner, because we are bringing together a number of different disciplines who work really in a unique way and in a way that we believe needs to be taken up more in practice. And we are trying this out in academia, but we're already creating and forging these links into practice. So a lot of what we do here in the academic setting, we believe can be transferred and is transferable into practice as well, because that's what we often see. So that's the reality. We see time pressure, fee pressure, contracts, language, interpretation of what somebody else might be saying, attitudes, cultural bias, and so forth. So we then have these educational differences that very much still pull through all the way into practice. So we are faced with this day in, day out. I've just researched for a book where I interviewed one of the world's most renowned architects, Patrick Schumacher, who is the principal at Zaha Hadid Architects. And when he talked about engineers, he said that in the past they were far too subservient and keen and asking the architects, tell us what you want and we can make it happen. And I think this attitude, as he says, needs to change. And he says that we want engineers to be more assertive and foreground the engineering intelligence more, rather than somehow, by whatever means necessary, realizing some preconceived form. And the same thing can be said about architects. Very often architects treat engineers as if they are just an afterthought, or what they are providing them, the information they provide them with might be an afterthought to their design. So it's really a learning process for both sides, and possibly then also involving other stakeholders in how we engage in a dialogue that's different. And the IDS, really, the integrated design process, is very much about addressing this, finding common ground, and a few other things. Very often when we see something like this, an engineer might say, this is a beautiful connection, whereas an architect might say, this is a mess. So everyone has the different views. Everyone has the different snippet, if you want, the piece of the pie that they are looking at, but not realizing it might actually be the same pie, but it just is a different lens on how to interpret information. And this is where, with the ideas, this is where we're trying to find out what are these differences, why are there these cultural obstacles, why are these hurdles, how can we overcome this? So when we set up the catalyst for integrated design, we very much started off by talking about common goals, focus on creativity and innovation, vision, intent, strategy, and culture, balancing individual and integrated design approaches, really embracing design as an open-ended solution-finding activity and not just a problem-solving activity, avoiding focused on detailed solutions too early. And this is something that we learned that engineers sometimes might want to tend towards, whereas the architects try to be quite open and exploratory. But we then have to find a balance, of course, in a collaborative working environment, we therefore need to set up flexibility and weave that in. We talk about common goals, so it's really about the formulation of the integrated design process, and it's those common goals are extremely relevant as part of that. We talk about focus on creativity and innovation, as I just said. So we need to make sure that this creativity and innovation can unfold, that people are given the time and the space to do that. We must avoid what we learn. We have to avoid too tight and deliverables that will over-constrain, in our case, the students' work and limit their ability to explore. And of course, it's a balancing act. So we really have to make sure that we set up this environment where this creativity, innovation can unfold, but without becoming too blue skies. So there is what we've learned. It's really important that we allow people to learn and adopt and influence each other early up front, but that there's also time for individual thinking and individual going back and advancing a certain thought, but then coming back to the group and resolving things concurrently, pretty much on the fly and on the spot. We realized that for the IDS, there were 4 key phases, I would say, that we are looking after. So we have a semester that is about 12 to 14 weeks long. So in the first 3 weeks, what we noticed is a lot about project inception. And this is the part where, particularly with the architecture students, they were learning a lot about the engineering component and vice versa. Engineering students learning a lot and understanding what the architects are actually looking for. So really generating those sort of basic principles. And in that phase, and sometimes this phase can also extend into week 4, 5, and 6, but it's a lot of new information that you need to absorb as a designer to understand what's relevant for the project. We then have seen what I would title criteria design, where with that base knowledge, the designers start to form their ideas, start to advance their ideas. There's a lot of interaction between the designers, the consultants, the architects, the engineers. So this is an absolute key period where design is still very much open and fluid, and everyone informs each other. And then you go into the more refining of solutions, what we have in week 8 to 13, really. And this is where typically we would then have a crit session at the end, where we would have review provided to the designers, where we would then understand, okay, what is, how does the output compare? Does it address all the key issues that needed to be addressed? And you will see a lot of the outcomes from my colleagues presented right after me. And as Brendan said before, with the vetting process, that then happens after that period, in 6 to 8 week sort of period, where we see then a lot of the engineering consultants, but also architecture consultants coming in, looking at the results and so forth. So if I break this down in a bit more detail, in those early sort of few weeks, it's a lot about establishing trust. So we talk about cultural issues that are relevant. We talk about making it clear what the distinction is between the traditional ways of working and the more integrated ways of working. We need to remove barriers. And sometimes, as I said, those cultural barriers and understanding where people are coming from in those early weeks. We have joint sort of assessment tasks that need to be generated. We need to introduce empathy and understanding where the other one is coming from, looking at the expectations and roles of the different participants, and also really explaining the integrated design process as part of that. In that criteria design part, the second part, really it's very important that everyone is a creator and co-author, so that we really break down the traditional notion of the architect being the designer and the engineer just helping to realize, really looking at encouraging the engineers to step in and work jointly as co-designers and not just respond to what they get from the architects by trying to realize it. We need to engage a lot of engagement, maintain a lot of engagement between the different disciplines, ideally also outside the class times, making sure when we start to think about the environmental solution that we prioritize passive solutions before active. So really instilling very early up front what with the building morphologies and so forth, and simple things, for instance, like where do you put an air handling unit if you want. So simple descriptions of where does everyone come from, really early up front, looking at solutions and innovation that are not just necessarily relying on active sort of mechanical systems. We then start to also look at common targets and performance, functionality, and so forth. Start to looking about integrated design, where you generate solutions on the fly, and that's quite important. So really this co-rationalization element of it. and allowing designers to start with educated guesses to then validate those guesses over time, which leads to the third phase where you start to really work on the solutions, integrated solutions as a whole. We started to see more focus on human comfort and environmental loads. We looked at joint sort of sessions for review, but also one-on-one between the architects and engineers, using multi-user performance metrics. And then really looking at, as Brendan said earlier, looking at solutions where you address not just one or two things, but via a joint sort of effort, you look at extrapolating that really and looking at more issues than just one or two with one idea, if you want. Then clearly we need to define the sort of characteristics of integratedness of what that means. Very briefly, and Brendan spoke about this, then there's the vetting process where we do some benchmarking, we develop a carbon catalog, and we do knowledge sharing as part of that. So it all feeds into across the different IDS that we're running, and I think we run about 10, 12. I think 10 of those at Melbourne Union, there's two, 3 more at the other institutions. So we really then gather that information, compare and cross-compare information, and feed that into knowledge sharing framework, present it, publish about it, and so forth. That's pretty much it for me. I think you're all curious to see some of the outcomes, and I'm going to hand over to my colleagues.
So I'm Shane Parkin. I'm Technical Director at Oricon in Melbourne, and probably one of my key focus areas has been in the data center space. One of those areas that are particularly, I suppose, pertinent in the current COVID environment that we've all been experiencing, and certainly made most people realize just how important and what a big role data centers are starting to play in our current working. So we were part of the IDS1 team, working with NEXTDC as a client and Greenbox as the architects, along with the university students. So probably just some background, I guess, is ultimately why do we think data centers are such a key focus area for this particular, I guess, design studio? Well, basically, they're massive users of energy. 20, 40, 60, 80 megawatt, 100 megawatt facilities and growing. And they continue to grow at 4% a year almost in terms of the electrical usage. So they're obviously a key area when it comes to energy efficiency and areas where we can make a lot of savings. To put in context, a 20 megawatt facility is equivalent to a fully developed city block in Melbourne city centre, whereas we've got facilities that are doing 5 times that on a single site. They're easily the largest users of power in the urban environment. They're probably only superseded by heavy industry and mining activities, in all honesty. They produce large amounts of low-grade waste heat, which is discharged straight into the atmosphere. Ultimately, the primary role in mechanical systems in these facilities is literally that, to get rid of the heat, and we just push it straight up into the atmosphere. What they do offer is that any small increments in energy efficiency that we can make on these facilities actually translates to pretty large gains in practicality. And unfortunately, they tend to have historically a very little interaction with neighboring sites, and they can be pretty boring, as much as we don't want to admit it. I think the image on the top of the page here kind of shows a data center. There's very little interaction with anybody going past it. You wouldn't know it's a data center, and therefore pretty boring. And I'm planning to say that's not a NEXTDC facility. So the project brief for the team was an 80 megawatt IT facility, which basically translates to 100 megawatt total facility load. Uptime tier 4 design, which I won't go into too much detail about, but basically we're talking about a fault tolerant data center design, top tier rating that you can get. Average rack power density of 4.5 to 13 kilowatts per rack. So if you think of a bar heater, it's 6, 7 bar heaters per rack. In a data hall, 400 racks, you're looking between 2 to 5.2 megawatts per 1,000 square meters of data hall. Carbon neutral initiatives ought to be targeted. In terms of the site, it's a 5-hectare site, 18-meter height restriction overlay on it, and as you can see from the diagram, in close proximity to residential areas directly across the road from the site. So as part of the projects, we saw 15 participating projects. They're all very different in the architectural design approach, which was interesting, and it certainly made for interesting viewing every week. There was some commonality around the approach to the carbon neutrality, as is to be expected, and were definitely not boring. To give you an idea, and I think some of these were briefly shown up in Brendan's slides, just to give you some idea of the kind of projects that came out of these studios. They were certainly interesting, and there were some great initiatives and some great, I guess, thinking outside of the box in a lot of the areas with these projects. Again, some of the thinking that actually went into this project, it certainly wasn't just an architectural exercise. There was a lot of thinking going into how the various elements of a project and the various parts of the projects interacted with each other, as well as what that impact is on the actual energy efficiency of this facility. And again, give you an idea of the scale of these facilities. This is again 5 hectares, fully developed. To put some impact, that you can sort of see the size of the lifts on these. These are big facilities. So in terms of the strategies and the energy renewables that we looked at on the projects, or at least that the students looked at on the projects, there was obviously some commonality approach to energy efficiency, and the I guess and the proposed systems that they implemented. The two main initiatives that we identified through the projects. One being carbon neutral power generation from renewable sources like your PV cells, and recycled waste. So things like omni-processors, which is really interesting that they came up with some of these. There was also recycling of generated heat to serve public spaces such as swimming pools and greenhouses. So again, making use of that waste heat, which otherwise would have simply been discharged to the atmosphere. When we looked at the photovoltaic cells, as an engineering overview of what the students did, we obviously assisted using some simulation software, as well as commercially available data in terms of efficiencies and other bits and pieces around the actual equipment that's commercially available now in the marketplace. This image probably doesn't do a lot of justice, but effectively you've got an indication of a PV canopy across the entire site. And what we looked at there was, based on that layout, you could typically expect with 25,000 square meters of photovoltaics, you could potentially produce almost 3,000 megawatt hours of electricity annually. So a decent amount of photovoltaics, and that's taking into account Melbourne conditions. One of the other things that brought up on the project was the idea of photovoltaic cells as part of a streetscape. So literally integrated into the roadways. If you think that these facilities are not heavy traffic facilities, there's certainly an opportunity there to produce some photovoltaic power from roadways, which don't tend to get built over. Based on some of these projects, we calculate about 757 megawatt hours of electricity annually just from that initiative. An omni-processor. So I guess the premise behind an omni-processor is that it takes the waste from the site itself, or in this instance, in proximity to residential neighborhood, there's potential of actually getting some waste from neighboring residents as well. And it converts it into drinking water and electricity through combustion. This is a type of system that's been championed by the Bill Gates Foundation into rural areas and low-income areas around the world, specifically for this reason. Using it in this application is different, and certainly one of those we weren't expecting. What we worked out is that obviously the water can be reused in water-cooled chillers, and electricity just fed straight back into electrical infrastructure to be used in the facility itself. Overall, omni-processor could conceivably produce 2,000 megawatt hours of electricity annually. In addition, we also saw some novel approaches of utilizing the low-grade waste heat. Thermal energy, there was an idea of using thermal energy exchange within the greenhouses and public accessible swimming pools, which in turn would reduce your loads on your chillers of the actual facility itself and the cooling towers, which means then obviously the cooling towers itself could be smaller, or they tended to operate, I guess, in a more efficient manner. Some further analysis on those ideas came up with was done using some IES modeling to do the heat gain within a typical greenhouse. And we looked at the impact of heat exchangers in the chilled water return lines to heat swimming pools. So this is an image from one of the projects, just showing the interconnection between the various swimming pools and recreational areas, as well as the greenhouse. And we calculated the thermal energy exchange with the greenhouse swimming pools in approximately about 7 million megajoules of heat per annum, which is about 0.3% of the total heat rejection of an 80 megawatt data center facility. In the final wash-up, so the total renewable energy power generated was approximately less than 1% of the total site power usage, which on its own and read in I guess on a single point like that, doesn't sound like a lot. But when you consider the scale of these facilities, 1% of 80 megawatts is 800 kilowatts of power savings, which is a mid-sized office building. We could literally power another mid-sized office building adjacent to this facility simply by those energy efficiencies and energy savings that they proposed in some of these projects. In the context of a smaller scale data center, if we were looking at a 10 to 20 megawatt facility, then suddenly those savings start showing at around 2.5%. So scale matters. And I guess as a bonus, the added benefit was that as a byproduct of the thermal energy from the facility, we could actually lead to community spaces like the swimming pool and the greenhouses to run almost for free, with no requirements for heating or cooling because of the waste heat from the facility itself. So from a community perspective, this was obviously a significant return. And I think that was pretty much it from me. So like I said, it was pretty interesting working through this with students who knew next to nothing about data centers when they started this journey. They picked a really tough project because obviously these projects are really technology focused and the forefront of engineering technology. So I think they did a fantastic job on it. And based on it, I'll hand over to the next person. Thank you.
Thanks very much, Shane. I think it's fair to say that data centers are probably the antithesis of the architectural project. It was really interesting watching as an observer. The looks on the faces of the architects as the engineers and client were presenting the technical brief on the project. It's a very, very different way of thinking. So,
if I could add something there, Brendan, just briefly. Obviously, the difference with these ones as well is that, as opposed to most buildings, data centers are engineering led and architecture taking the back seat. So it was actually quite interesting to see the flip as well, with architects taking a bit of the lead in designing a data center. That was really interesting.
So we thought we'd just explore a couple of the experiences from the studio from Gerard Page from Greenbox, so the consulting architects involved, and from Jeff Van Zitten at NEXTDC, so the client essentially. Gerard, did you want to start? Do you have any observations you'd like to share?
Yeah, it's an interesting comment from Shane about architects taking the back seat.
I'll tell you what, we might swap over to Jeff to offer a couple of comments, and we might come back, Gerard, at the end.
Can you hear me?
Jeff, do you want to share comments as a client? How did you find the process?
Look, I found it thoroughly intriguing, enlightening and refreshing. It was great to see all these young minds take such a different approach. I understand very much what Shane was saying in terms of it is usually very much engineering led, though to be clear, JED has always been a key part, and it is very much integrated design in its purest, though with a very heavily engineering bent. So, I commend the architects having to do this without any real engineering students to work with them. So again, a key lesson learned for me would be for the future, we would very much hope to get more engineering students involved in these. I think that would be critical for their improved future success, as we've discussed. And to that extent, a lot of the ideas generated were, from an architectural perspective. I think some of them have flowed through to what we've actually done on the site. The one I liked the most was the modularity and the prefabrication, and that's something which in a large way you will see translated into this site in a real way. It was a bit of a shame in some regards from an engineering point of view that we didn't have more engineering on the engineering design and some of the less glamorous things to do, which actually save a lot of energy, which we're currently working on in the background as a team now, which is, it's good old, and Era would love this, good old simple economy cycle ventilation. When you've got that many megawatts of computers, ideally you'd let them ventilate themselves. I'm sitting on the back deck of my property in Brisbane, and it's been 35 degrees and my computer's working just fine. And I've got natural light and natural ventilation, and it's in a sort of microcosm what we should be doing with our data centers. So a lot of the economics of that is where the challenges get with attenuation and interfacing with the community, with noise. And so it would have been good to have a bit more of the engineering developed through looking at the commercial realities as well. So some lessons, I think, for the architects. Now, I would love to see the looks on their faces when they see our final design. I think there'll be gasps of horror, but it will be a big lesson learnt, because we did say during the brief that, the minimum was 60 megawatts, and if we can fit more, we'd like to see how much we can fit. And they did design some beautiful parklands and other things which are truly beautiful. But as a commercial organisation, the reality is, we've ended up with a facility that can have 100 to 120 megawatts of IT load on it and a cafe. So, there's some commercial reality, I think, which will be a big part of this process that the students will get out of this when they see the final product. And they might go back to thinking about how during it we said, could you see how much more capacity you could fit? Having said that, it was fun to let them go and see their creative talents, explore different ideas, some of which we've been able to incorporate, probably not on the scale they would have liked had it been a half government-owned site rather than a private investment, I guess. But to wrap it up, I loved it. I really enjoyed it. It was refreshing. And I think, just if we get more engineering students involved, that would be really important for the future.
Yeah, thanks, Jeff. Just to give a bit of background on those comments from Jeff about the engineering students, unfortunately with COVID, our engineering colleagues were impacted a bit more than the architectural faculty in terms of student numbers. So a lot of the students that were signed up were trapped overseas just as the studios were starting, and there was a hurdle requirement which meant you needed to attend in person, something that isn't the case now. So if we're doing the same studio again now, in fact we are, we're able to get the engineering students involved. So in that first round for the first two studios, we were relying on the architectural studio students just dealing with the engineering consultants, which meant that there was a lot more work for Bill and Shane and Peter from Oricon. And like Jeff said, probably we didn't get to explore in depth some of those engineering aspects quite as much. I can see Lou A is from Melbourne School of Engineering is online as well. Lou, feel free to chip in if you like. Look, we're a little bit behind time, so we might keep pressing on. Jess, do you want to take us through some of the technical findings on the schools quickly if you can? So Jessica Hogg from Arup.
So hi everybody, I'm Jessica Hogg. I work as a senior consultant in the Sustainable Buildings team at Arup. It's been a real pleasure being involved in the studio over this term, and the focus on schools. I've certainly been really inspired by all the students' enthusiasm. So our project incorporated 2 existing schools within the ACT as case studies. And the timing of this studio was very fortunate in the fact that the students were able to go to Canberra and visit these existing schools before really the restrictions for COVID came into place. So they got to go and meet with Beth as the ACT representative, with the staff that work within these schools, and to really kind of have a look around the buildings and to see for themselves some of the areas of concern and issues with the energy performance and the thermal comfort of the existing buildings. So the brief for the students was to refurbish the schools to achieve net zero carbon, but also to incorporate a new build extension as well. Now, the identification or the clarification of what net zero carbon is was really kind of left open to them to define, noting that it is a term that is used interchangeably for operational energy consumption, but also looking at embodied energy, which some of the students also looked into, and then energy or carbon associated with things like refrigerant impacts as well. So for us, when we've undertaken the vetting process, we've looked at it just from an operational energy perspective, but certainly being cognizant of the fact that retrofitting, refurbish existing buildings has a huge beneficial impact from an embodied carbon perspective. So the two existing schools were built in the 1950s and 1960s, mostly kind of uninsulated. They do have some solar PV on the top. They're heated by gas, and you can see from the charts that I've got on the slide that gas is the real biggest use of resources. It's a huge part of the energy consumption, and shows really just that it's very heating dominated. So with the older building fabric and likely lots of leaks through the existing envelope, needing to have a good amount of gas to maintain a comfortable temperature for that learning environment. So one thing that it was important to consider with schools as they are learning environments is the indoor environment quality. So obviously it would be easy to have a low energy building if you don't have any heating and cooling in it. So making sure that there was this focus on improving that thermal comfort and also the indoor air quality as well. So there was a lot of talk about opportunities for mechanical ventilation systems to provide fresh air to maintain suitable levels of CO2 within those spaces. And the students were really kind of took this on and took that challenge to not just be looking at energy, but also the bigger picture, looking at it more holistically and really thinking about those building users who they'd actually had the opportunity to meet as well. So the student proposals, we ended up with 11 submissions overall, and they were also very wide ranging. It was really interesting to listen to, or to kind of be involved in the creative process, really, and the challenges that come with having an existing building. So some of those kind of basic passive design principles that it's much harder to incorporate when you already have the building form set, but seeing them then take the new build extension opportunity and really running with that and kind of working from that, reducing consumption as a starting point. So once we had the 11 submissions and we kind of disseminated and formed together all of the different initiatives that had been proposed, the vetting process that we went through, we used the Rhino software with its associated plugins, so Grasshopper, Honeybee, and we run quite a number of simulations looking at each of these initiatives in isolation to really kind of quantify how much energy could we save based on the hypothetical building. So the geometry we actually took from one of the existing schools, and this represented kind of a portion of the building, but it had the classrooms, it had some offices, it had a staff room, the ancillary areas. So it seemed to be representative of the schools at large. We did a bunch of post-processing in Excel and also did a bunch of handouts as well for those additional elements that we don't use within the energy modeling software, such as toilet extract ventilation, for example. What we ended up doing is that we took a base case situation, so an uninsulated building envelope, gas boilers, no solar panels on the roof, and moved through looking at each of those initiatives through passive design principles, so insulating all of the building envelope, putting in really good performance windows, the air tightness improvement, so looking at a best practice level and also a passive house level of airtightness, incorporating shading. Then we electrified the building, and all of the students' submissions actually had electrification. I think this is a really key note with the definition of net zero carbon. You could, in principle, still be consuming fossil fuels and then purchasing carbon offsets, whereas the students all were really keen to actually have all of their resources coming from renewables. So moving to a heat pump, electric heat pump rather than gas-fired boilers. And then also reducing energy further through the services design. So incorporating mechanical ventilation, as discussed, with the focus more on indoor air quality rather necessarily than energy efficiency, and improving the lighting system. So this then created our best case, and we compared the base case and the best case across each of those initiatives. So looking at some of these results, so this is where we started with the base case and apply each of those initiatives in isolation so we can get an understanding of where the best effort is made. Now, obviously, some of these you would want to be incorporating many of them at once to get the best benefit, but really it helps from a comparison perspective. So the top chart is showing energy demand. So that's the heating demand in the red and cooling demand in the blue. I guess some really key takeaways for me from this, which I thought was really interesting, was about the impact of infiltration. So we assumed a fairly leaky building envelope as our base case. And then moving, so kind of in the middle of the chart, you can see we've got just improving to a kind of best case average infiltration, reduces your heating and cooling demand by about 23%. If you move to passive house infiltration, then you're down at 35%. So when you do have that high level of infiltration, you would want to make sure that you're incorporating mechanical ventilation as well, so that you're not causing any problems with the indoor air quality. And so if you look at the far right end of the bar chart, you can see if we incorporate the mechanical ventilation with heat recovery and improve the infiltration rate, we end up reducing the heating and cooling demand by about 60%. And there'll be huge benefits for the thermal comfort of the space or the indoor environment quality, because you're removing all those gaps and cracks, the leaks within the facade, whilst also providing enough fresh air to have a really high quality space. The chart on the bottom then looks at the actual overall energy consumption, and for this we determined the base case is all electric. We thought it would be a little bit unfair to be comparing with a gas boiler, and so to keep a level playing field, then you can see the impact there. The biggest impact is with lighting, so moving to current code compliant lighting from older kind of inefficient fluorescents will reduce the energy consumption overall by 40%, which is huge. We then switched it around, and so we took the best case and then we removed some of the initiatives to then see the sensitivity in that direction, and kind of tells a very similar story but in the other way. So we've got the infiltration, which is really the highest impact on heating and cooling, removing the heat recovery from the ventilation system. So this is really key within the Canberra climate, within the ACT climate. Those cold winters, you really get a benefit from incorporating heat recovery on your ventilation system. And then overall on the energy side, we've got a massive increase in lighting consumption when you move to inefficient lighting from your LED. So overall, moving from the base case to the best case, we get an improvement in energy consumption by nearly 70%. And to be honest, this could probably be improved even more with more of a review around efficient equipment. So we just maintained the same equipment loads in the two cases, and also looking at lighting controls as well could be another opportunity for reducing that energy consumption. And given the layout of the schools with the favourable aspects and with a single-storey development with a nice large roof area, the results indicate that it would be there would be an opportunity for the building to not only be net zero carbon overall, but actually net zero energy. So there's enough space on top of the roof to have PV panels that would produce over the course of the year enough energy to be able to serve the whole development demand. So that is it from me. But yeah, it's been really interesting spending time creating these ideas with the students and seeing how engaged they are. I definitely felt at the end of each of the studios feeling inspired again and feeling very hopeful about the next generation of architects and engineers coming through and facing the climate emergency that we're in. So thank you for letting me be a part of it.
That's great. Thanks very much, Jess. We'll move on quickly. I'd like to give, we've had some we've been very lucky with the studios, with the clients in NEXTDC and Beth from the ACT and the consultants as well. Everyone's really engaged fully and put in over and above. I'd like to sort of pass to Beth and Nick and Damon, if Damon's around. Damon Van Horn from Grimshaw was involved as well. Does anybody want to share some the top experience you had, good or bad, in the studios? Damon, maybe we start with
you.
Yeah,
sure. I'll jump in, Brandon. Look, I just agree with what Beth was saying. It was kind of an honor to be part of the studios. I thought they were very educational for me. And I have to say, considering the challenges that we brought to the student group, it's really amazing what they were able to pull together when you think about the amount of new information they had to digest to then synthesize into design. I think it was unlike any other studio I've seen. And I guess one thing that I came away thinking after this process was perhaps a way to get to help the students a little bit would be to narrow the brief slightly in a way that would potentially require the consultants who would be engaging into the studio to have a little more of consensus ahead of the studio commencing. So for example, with the schools, if we were able to maybe agree on a specific energy tool to use, Passive House, for example, that might have been a way to enable the students to focus a little more, because of that amount of information they had to synthesize, there was a bit of kind of time of spinning when they could have been more focused. But again, looking back as I just was recently at the outputs, it was pretty phenomenal considering all of that.
That's interesting. I think that sort of points to what you were saying, Dominic, about that time to get up to speed with the technical side of things. Nick and Pat,
I'm more than happy to have a say. Look, I really thought that the studios, we had a number of different people, particularly in the second studio, join and advise the students. And one of those included someone who's has a key role in developing our design standards moving forward. For the Education Directorate, I think it really allowed our planners and our asset managers to see the natural connections between their different expertise. So at different stages, we had pedagogy people, capacity people, sustainability people. And I think, I know that this experience for us has actually allowed enough people to get that understanding of where we can go, that it has allowed us to envision a pathway that could drive our schools towards zero emission. And I don't believe without that level of knowledge growth within the Education Directorate that we would have gotten there at this point in time. I think for me, the thing that I really enjoyed seeing was there were some students who really took that extra step. So they were integrating not just the architectural and the engineering, but those ones who took the extra step and started to look at how does the landscape actually interplay in this model, that to me was the sign of where we really could go, because urban heat island mitigation, as we saw at some of our schools, is a really key thing. If you've got a vegetated and a well-grown courtyard, then you're actually going to continue to minimise your energy requirements across the site. I think for the schools, and the comments that I have had back from the principals were that it has given them a totally different vision to where their schools can go. So instead of saying my classroom's hot, let's put some split systems in, they are starting to actually really think about a 5-year, 10-year horizon rather than just what I need today. And I think that that's a really key learning for the Education Directorate and the students, because it puts us on a path to the integrated design that we started out wanting to achieve, because we've got a growth of knowledge across everybody. For the students, I'm just really excited that these students, I just found their stuff was absolutely exceptional. And, as we move forward with new pedagogical needs and ways of looking at teaching and learning, these students are coming along for the ride, and they're going to be able to advise very well on what the implications are of some of the design choices from a pedagogy perspective. And that is one of the key areas that where I see new buildings fail, is that they are great from a pedagogical perspective, but when it comes to an engineering and an efficiency perspective, they really don't hit the mark. So I think these students have just had this incredible experience that will really put them on good footing to be a big part of this transition to a low emission future.
That's really good to hear, because that's part of the aim, is to produce a different type of architect and a different type of engineer.
Yeah.
We're right on, almost out of time. Nick, do you have a very quick comment you want to?
I'll be, super quick. Really impressed with the students at how well they adapted to the whole program and the shifting process of COVID. I think they were really resilient and really adapted well. It was music to my ears to have architecture students talking about ground source heat pumps, air-to-air heat exchangers, and comparing the relative benefits of biogas and algae facades and PV. So that was a big win. Really enjoyable to be part of that. I think the education process is really important. So this sort of thing is a fantastic program to have within both engineering and architecture courses, to start to train that early, this way of thinking. And then I think the next challenge is really industry. And I think, Dominic, your quote from Zaha Hadid at the start is really relevant about engineers solving a problem which doesn't necessarily need to be there in the first place. So engineers need to rethink the way they tackle problems. And that's an industry problem, which we've all got a part in changing.
Yeah, that's great. Thanks, Nick. Maria, I know we're out of time. I just wanted to say they're very different projects. You've got data centres with huge amounts of energy and got lots of interesting opportunities for adjacent usage and empathy across swimming pools and other things for community. And then education environments where carbon zero is possible. And I know in the States there's, and probably here too, there's consultants making a niche market out of actually developing schools and paying all of the fees and capital costs back out of the payback period for energy savings. So it really is possible to do. So what was the question that showed that waste heat could be used theoretically for community usage, business and cultural perspective? Are data centres open to the idea? It's a really good question, Wendy, and it's something that's a question for the boards. I know that boards often don't like getting involved in non-core business, but I also know that the competition for data centre sites is quite ferocious at times. So if a data centre operator like NEXTD was able to approach a council who are thinking about building a swimming pool and actually say, we can actually build you a data centre next door which will power your swimming pool for free, that's got the potential to become a negotiated development discussion rather than a open tender for a site. So I think that there absolutely is the commercial opportunity to do business around those things and to get an edge over the other data center operators who might not be quite as innovative and free thinking as NEXTDC. But yeah, we'll put that to Jeff and just and see what his views are on it. There was one other question there as well, I think. I see heat rejection is much higher than the pool heating required. Yes, that's right. And Lou's answered that one as well. Are there any other questions around that you're seeing, Marie?
No, Brendan, nothing else has come through. If anyone does have anything just before we wrap up, please feel free to type it in. Otherwise, we might start wrapping things up there, Brendan.
Sure. I'd just like to add a couple of comments or just highlight some of Dominic's work. So Dominic's been looking after the findings from an integrated design research point of view, while the others have been presenting on the building typology technical findings. And it has been interesting seeing the difference between the theory of integrated design and the practice of integrated design. So there's a couple of big things that we found were different to the theory. One is that it's not a one-size-fits-all. So all of the integrated design processes out there, they look really good on paper, but once you try to marry them with individuals' ways of working, and architects and engineers have very different ways of working, and there's rockstar architects and rockstar engineers, as we all know, who have very specific ways of doing things. It's naive to think that we can actually force those into a box to actually make it happen in a predetermined integrated design process. That's been very important, as Dominic said, to maintain flexibility and to change it around the individuals involved. The other one is that it took a lot longer than we thought for people to get up to speed. So for architects to actually understand what the engineering challenges and opportunities are, and vice versa for the engineers to understand what the architect's job and what those constraints and opportunities are as well. So we originally thought that all of the ideation would happen in the first 2 to 3 weeks, and it actually ended up happening about mid-semester. And then the last one we found was everyone talks about common goals and aspirations. We found that having common aspirations wasn't enough. Everybody wants to do good design by the planet, but actually we really found that people started to gel together and work together and come up with some really good ideas once they had some detailed work to do together as well. And so this speaks a little bit to what Damon was talking about, and Dominic earlier as well, having some common software that we can use that's not so technical that an architect can't use it, and vice versa for the engineering. Actually having them work on some detailed stuff together as well, that really actually engenders a team with a spirit of team working together. And I think that's about it. So we might as well wrap up there unless any of the panel have last comments they'd like to add. I'll take that as a no. So Marie, we might wrap it up.
Yep, sure. So thank you everybody for registering and attending today's webinar. And a thank you goes out to our activity leaders and all of our presenters for today's webinar. As mentioned, this webinar is the first of the iHub webinar series, and we would love to see you at our next 2 sessions on Data Clearinghouse tomorrow and our Living Labs, which is held on Wednesday. Both of these sessions will be held at the same time of 12:30 PM Australian Eastern Daylight Time. For more information regarding iHub and to register for the other sessions, please visit the website up on your screen, so ihub.org.au, and we look forward to seeing you again next time. So thank you again, everybody, and see you next time. See you later.
I'll just quickly add in while we're waving goodbye that there have been detailed reports produced from both of those studios, and those reports will be made available publicly. So have a look out on the ERA website, and if you don't see them, get in touch with Marie or myself and Dominic and Lou, and we can give you a copy.
Yep, they will be posted up on the ERA website and also on the iHub website as well. So feel free to check those out. Thanks, Brendan. Okay, so thank you, everybody.